A. Show that tan squared x plus cos squared x equals sec squared x plus a half cos 2x minus a half, and hence find the exact value of the integration from 0 to pi over 4 of tan squared x plus cos squared x dx. So the first step is to rearrange tan squared x plus cos squared x into sec squared x plus a half cos 2x minus a half x. And we need to do this by using the trigonometric identities. So a lot of you, when you do this, you don't know where to start. Which identity are we going to use? So when you pick the identity you're going to use, you need to observe and look at both sides, or look at what you're trying to rearrange the expression into. In this case, we start with a tan and a cos. So we start with tan x and cos x. And we want to rearrange it into some form of sec x and cos 2x. So let's look at the formula sheet. From the formula sheet, we can see that there's an identity that involves tan squared theta and sec squared theta. So we're going to use this one to turn tan x into sec x. So that leaves cos x and cos 2x. So we need to look for an identity that has cos x and cos 2x. And there's one at the bottom there for cos 2a. Cos 2a equals 2 cos squared a minus 1. So we could use 2 cos squared a minus 1 to turn it into cos 2a. So now we have an identity to turn cos x into cos 2x. And before you use them, we want to replace the tan squared x. So we need to rearrange the identity 1 plus tan squared theta equals sec squared theta, so that tan squared theta is the subject of the formula. Well, in this case, tan squared x would be the subject of the formula. So if you do that, tan squared x equals sec squared x minus 1, and we will use this to replace tan squared x. And then from the other identity, 2 cos squared x minus 1 equals cos 2x, we want to use it to replace the cos squared x. So we need to make cos squared x the subject of the formula. So if you do that, cos squared x equals a half cos 2x plus a half. This means we can use this to replace the cos squared x. So if we do that, and then simplify and rearrange it, we have the exact expression from the question. We have sec squared x plus a half cos 2x minus a half. So the first part of the question is done. And now we need to integrate it. So with these A-level questions, if they ask you to prove an identity, then they ask you to integrate or differentiate it. It means they want you to use the expression that you proved was equivalent to it to integrate it. So we're not going to integrate tan squared x plus cos squared x. We're going to integrate sec squared x plus a half cos 2x minus a half instead, because it will probably be easier. And it's the same thing anyway. So from the formula sheet for integration, we can integrate sine x, cos x, and sec squared x. So we can integrate the sec squared x part and turn it into tan x. For cos 2x, integration of cos x equals sine x. So integration of half cos 2x will be half sine 2x, but then you need to divide it by the differentiation of what's inside the sine function. The inside is 2x, so you need to divide that by 2 as well. So that becomes half of sine 2x divided by 2. And then integration of minus a half is just minus a half x. And then if you integrate it from 0 to pi over 4, you want to substitute the x with pi over 4 and then subtract it with the substitution of x with 0. So if we do that, So the question wants the exact values. So we need to give the exact values of tan pi over 4 and sine pi over 2, for example. So tan pi over 4 is 1. Sine pi over 2 is also 1. So that's 1 plus 1 over 4 minus pi over 8 for the substitution with pi over 4. Subtract 0. Because when you substitute all those terms with 0, it equals 0. So therefore, the integration is 5 over 4 minus pi over 8. And that is the answer. Part B. The region enclosed by the curve y equals tan x plus cos x and the lines x equals 0, x equals pi over 4, and y equals 0 is shown in the diagram. Find the exact volume of the solid produced when this region is rotated completely about the x-axis. So the diagram shows the curve y equals tan x plus cos x. And to find the volume of a solid rotated around an axis, we have formulas for that. So rotated completely about the x-axis would be pi multiplied by the integration of y squared dx. Okay, this formula isn't given in the formula sheet, so you have to remember it. So volume would be integration of pi from pi multiplied by the integration from 0 to pi over 4 of y squared dx, and y in this case is tan x plus cos x. So we're going to integrate tan x plus cos x squared, which sounds familiar to part A. So if you expand the brackets for that, we get tan squared x plus 2 tan x cos x plus cos squared x. And we can't integrate this because looking at the formula sheet for integration of trigonometry, we can only integrate sine x, cos x, and sec squared x, which is none of those terms. But remember the question in A levels, they like to lead you to your answer. Sometimes if you're stuck, look back to the previous part of the question. And in part A, they ask you to find the integration from 0 to pi over 4, exact numbers, of tan squared x plus cos squared x dx, which is 5 over 4 minus pi over 8. So part of this integral in this part of the question, you already know the answer to. So if I rewrite that as pi integration of tan squared x plus cos squared x dx and then separate it from the 2 tan x cos x part, we already know the answer or the value to the first part of the integral. So the first part will be equal to 5 pi times 5 over 4 minus pi over 8. And we still need to find the integration from 0 to pi over 4 of 2 tan x cos x dx, which we cannot do from the formula sheet. So when you cannot integrate trigonometry, you need to use the identities to turn it into some form that you can integrate. We want to turn it into sine x, cos x, or sec squared x. One of the most commonly used identities for tan x is that tan x equals sine x over cos x. So if we replace the tan x with sine x over cos x in the integral part, and also take the 2 out, so that's plus 2 pi integration from 0 to pi over 4 of sine x over cos x multiplied by cos x dx. The cos x and the cos x over here cancel out, leaving only the integral of sine x, which we can integrate. So that equals the integration of sine x only and integration of sine x is minus cos x. So we have pi multiplied by 5 over 4 minus pi over 8 plus 2 pi multiplied by minus cos x from 0 to pi over 4. Okay, so let's substitute 0 and pi over 4 in the integral. And we want the exact values here. So we need to give the exact values of cos pi over 4. Pi over 4 is 45 degrees. So cos pi over 4 would be 1 over root 2 plus minus cos 0. Cos 0 is 1, so minus cos 0 will be plus 1. So we have all the terms in numbers now. If I take the pi out from every term, so all we need to do now is just simplify the numbers and clean it up a little bit. Okay, let's not leave a square root at the bottom of the fraction. Okay, and now we've taken the pi out so that it's a lot simpler. So therefore, volume equals pi multiplied by 13 over 4 minus root 2 minus pi over 8. And that is the exact answer, no rounding.